My name is Marc Wein. I'm a deputy editor for the Journal of Bone and Mineral Research. In 2026, the JBMR will be celebrating its 40th anniversary. This interview today is part of a year-long 40th anniversary celebration in which we're highlighting the leaders in our field of bone and mineral research. To mark this anniversary, we're hosting a series of interviews with the most distinguished leaders in our field to discuss their pioneering discoveries and careers. Today, it gives me great pleasure to be here with Dr. Henry Kronenberg. Dr. Kronenberg, or as he is known to many of us, Hank, is a professor of medicine at Harvard Medical School and served as the chief of the endocrine unit at Massachusetts General Hospital for over 3 decades. Hank's research group cloned the genes for parathyroid hormone and its receptor, and pioneered the use of genetically modified mice and lineage tracing to study bone development, bone remodeling, and the relationship between bone and hematopoiesis. Hank served as the president of ASBMR in 1993 and as the Endocrine Society president in 2016, and was recently inducted into the National Academy of Sciences. Hank, it's truly a pleasure to be here with you today.
Thank you, Marc.
To start out our conversation, would love to hear you reflect on influences in your career. What or who had the strongest influence on your career?
Certainly the single person who had the strongest influence was John Potts, who was my mentor at Mass General and was a real role model for how you could be a clinician scientist. And he grew up in science as a protein chemist when molecular biology meant protein chemistry. And what he did is, by spending lots of time determining the sequence of parathyroid hormone, he used that to make a radioimmunoassay, and then used the radioimmunoassay to ask a number of both physiological and clinical questions about parathyroid hormone. It was a real model for how to expand science and build a career. And I've sort of followed in his footsteps and really done the same thing, but of course, like 20 years later, and so instead it was DNA instead of protein, and so cloning parathyroid hormone was the obvious first thing that I did, and if I hadn't done it, somebody else would have done it at about the same time. So that wasn't exactly brilliant. I think that the thing I'm proudest of actually isn't the cloning of that and cloning of the receptor, though I'll say a little bit about that in a second, but it was the work showing the relationship between parathyroid hormone-related protein and Indian hedgehog in regulating differentiation of the growth plate, because that wasn't self-evident, and I think that was a very useful way to think about bone growth. And so that's, if I had to say that I've done anything that would have taken a few more months for somebody else to come up with anyway, then that would be it.
That's really incredible. Thanks so much. I guess I'm wondering if you could expand a bit more on kind of the role of collaboration in thinking about this seminal discovery about the role of Indian hedgehog and parathyroid hormone-related protein. I know that some of that work was done with other investigators, and so.
Well, Cliff Tabin is a developmental biologist who I've collaborated with over a number of years, and both in this particular project, but also more broadly, I've learned an enormous amount from his developmental perspective. And so that I don't think that this work could have gotten done without that particular collaboration, and with Andy McMahon as well. Andy McMahon cloned Indian hedgehog, and so he and Cliff and I started out as rivals in this. Well, Cliff and I were together, and Andy was a competitor. But Andy is also a close friend, And when those papers finally came out, then what we decided the logical thing to do was to write a grant together. And so we wrote a program project that continued to fund this work for more than a decade, and it was an enormous amount of fun.
Wonderful. I guess going back to the kind of you mentioned some of the scientific contributions that John Popps played in kind of as an influence in your career. Are there other kind of ways that he influenced kind of your leadership perspectives or kind of how you approached mentoring?
Oh, well, that was easy. I pretended I was John Potts, but younger, and tried to do whatever he had done because he's a very special man. And one of the most important things, I must say, I learned from him, and you'd think it's obvious and that everybody says they do it, but he thought of mentoring as finding a way to design programs that bring out the best in people, and each one's different. And he does it not just to build his own portfolio, but to help people along. And I must say, it was clear and totally self-evident to anybody who worked with John that what he cared deeply about was what was the careers of the individual people who entrusted their careers to him, and he didn't disappoint. And that was certainly the leadership model that I've always striven to emulate. That's for sure.
So I guess at this point, I would love to transition a bit from your own mentors and research to our society. I'd love to hear you reflect a bit on the impact of the ASBMR and the JBMR on your career over the years.
Sure. Well, they are more or less coincident in time. The ASBMR started in 1979. I was a clinical fellow in endocrinology in 1975 and 6 and 7. So I was really building my career just when the ASBMR got started. And I must say that I didn't go to the first ASBMR meeting, and I thought, oh, it sounds like a very super specialized group and maybe interesting and maybe not interesting. But then I heard from all my friends who had been smart enough to go to the first meeting what a spectacular meeting that was. And so I went to the second meeting, and I was hooked and have gone to everyone since then, except if I've been sick or something like that. My growth as a scientist has been coincidence with ASBMR, and the that's important because both in those days there weren't that many outlets to guide one's scientific career. And so ASBMR, by bringing bone and mineral metabolism together, really became a formative place for me. And I must say, I was at first, well, not skeptical exactly, but skeptical is, I suppose, the right word. I wasn't interested in bone at the beginning of my career. I was interested in endocrinology and calcium and parathyroid hormone, what regulated, how they regulated each other, and wasn't that neat? Endocrinology stuff. And then bone came along, and I must say, well, my first impression of bone was boring. It's osteoporosis, ugh, and it's something I needed to do, but I wasn't terribly interested. But then, to my embarrassment, I learned how incredibly fascinating and complicated bone biology is, much more so than just, say, parathyroid hormone, calcium homeostasis. So, which is complicated for other kinds of reasons. But so my respect for and then fascination with and spending my career really studying bone biology more than just calcium metabolism, what was heavily influenced by the ASBMR. Because it was, the ASBMR is loaded with lots of people who think of bone as the most important organ to study, and I can understand that, and I share their enthusiasm. And so it's totally guided my career. There's no doubt about that.
Well, thanks so much. I guess in the final question I have, kind of would love you to kind of start to think forward a little bit. I actually wanted to pull up a picture. Let me see if I can do this the right way. Here, can you see this picture?
Yes.
Um, wanted to show you this picture. It was taken at a Gordon conference meeting early in 2024. As you look at this picture, I'd love to hear your reflections and to hear what message or messages you would want to share with the next generation of scientists who are studying endocrinology and bone biology.
Well, thanks, Mark. This is an amazing picture. Thank you very much for sharing it. Uh, the all five of these wonderful people, Sengwan Kim, Joy Wu, Krista Meese, you, and Noriaki Ono, all have been fellows in my group at one time or another. And what this picture reminds me of is the old saying, which is absolutely true, is that you're only as smart as your most recent postdoctoral fellow. And I was extremely fortunate to have these brilliant people join me in the laboratory. And each one of them taught me things I hadn't known before and made me think about projects I wouldn't have otherwise thought about. So that it's an emphasis. The other thing that's obvious about this picture, it's so obvious that you don't notice it or think about it, is how many backgrounds these people have. And I don't mean just what background in science, but what country these people come from, what their personal backgrounds are. And it's amazing how bone science is so international in its perspective and flavor. And of course, we take that for granted, don't even think about it much anymore. But as you know, I've been extremely fortunate, as have you, Mark, that by growing up in the United States, we grew up in an extremely wealthy country, number one, but number two, a country where that was very interested in science, and that led to much of the scientific literature being published in the English language, so that I've never had to think about language as a challenge, but just the opportunity to have all kinds of people come to the United States to study bone biology with people in the United States, which has been extremely fortunate for me, that's for sure. And the opportunity that science has given so many people from around the world to learn who each other are and how different and how similar we are, and to then visit each other when they go back to their original home countries, as some do and some don't. Then is a very special part of science, actually, that isn't talked about enough, I think.
Absolutely. Hopefully now. And I guess just in the final few minutes that we have together, are there any messages that you have for the next generation of scientists as you look back on your career? How should we be carrying the torch forward?
Well, obviously, it's an important torch to carry forward. And I think, I don't mean it's getting easier. It's never easy, because discovery is never an easy thing to do. And I guess the most important thing I would say for every scientist is to think very hard about what problems excite them, because you want to be doing something that's really exciting, because most of the time it doesn't work, and that's frustrating. And so you want to get over those valleys so that you can get to peaks, and the peaks are pretty exhilarating. The ability to discover something that wasn't discovered before is a real privilege, and as is an exhilarating experience that every scientist discovers. And I guess what I'd say is that because it's so hard, and it is hard to do something new in science, the thing that's really important is to make sure that you're doing something that you think is worthwhile. And you want to study important problems, not just solvable problems, but you want a solvable problem too. And that's the tricky part, finding a solvable problem that is important and hasn't been solved yet. But it's got to be an important problem, otherwise it's not worth doing. So I guess that's the most important thing, is choosing things that you find fascinating and that you know from literature and from friends and others, colleagues, that these questions are important problems. You don't want to fill in details. You want to come up with something new. And if you're doing that, then you're doing the right thing.
Wonderful. Well, thank you so much, Hank. I really can't think of a better way to kick off the JBMR's 40th anniversary. I really appreciate you taking the time to share your insights with us today.
It's a real honor to have been asked. Thank you so much, Marc. You take care.